Thanks for coming, everybody. I know we're across the street and it's raining, so thank you for coming. We're super excited to talk about Virtual Kubelet today. I have a bunch of stickers too, so if anybody wants a cool Virtual Kubelet sticker afterwards, come see me and we'll pass them out. So I'm Jeremy, and this is Brian. Hi. We work at Microsoft on Virtual Kubelet, amongst other things. And we're going to go into a deep dive today. So why are we here? Why are you here? So Virtual Kubelet's a pretty new project in the sense of, in the scope of CNCF. It recently got accepted as a sandbox project. It's been around for about a year though. And we've had a small community kind of coalescing behind it. So today we want to talk about what Virtual Kubelet is, so everybody has some context about why you would want to use it, what it does. And then we'll also go into a little bit of context on how it's structured, how the code is laid out, where you might find things if you're looking to either implement new capabilities or features for Virtual Kubelet, or if you want to fix some bugs, or if you're just curious about how it works and you want to use it. Before we get into what VK is though, let's talk about what a kubelet is. So we're going to talk about a virtual kubelet. What's a kubelet? So a kubelet is a software component that runs on your nodes. And its real responsibility is to make containers run on that node. So you make a pod in Kubernetes. The kubelet's what's responsible for actually making that thing run. It does some other things too, like expose synchronous endpoints for getting logs and execing into the container. And we're going to go through mostly the creation of the pod and running of the pod today. So let's think about how the kubelet works. When a node comes up and gets registered in Kubernetes, the kubelet's installed on it, and it's configured, and it has a name. And then it says, hey, Kubernetes API server, my name is whatevs. I'm a node.
What's up?
So at that point, you've got a node registered with Kubernetes. And then you, as the awesome Kubernetes user, can say, hey, I need to make a pod spec. Here's my pod. Please run it for me. It may or may not have some constraints attached to it. You create that into via the API. And then the scheduler says, oh, hey, there's a new pod. I need to figure out where to assign that to. Whatevs has some space. Let's assign it there. So it updates the pod spec and says node name is whatevs. Meanwhile, the kubelet is running, and it's doing a watch, because it's just a Kubernetes client. It listens on the API and says, give me all of the pods that have spec.nodename equal to my node name, which is whatevs. So you've created your pod, goes to the API server. The scheduler says, this thing can go to whatevs. So this, in this flow, the kubelet picks that up and then says, what do I do with this thing? It needs to reconcile the state. Is it running? Is it not running? Do I need to make it running? It figures out what to do, and then it uses a CRI to start the container. So that flow happens on whatever node you have in the system. And the kubelet is really kind of abstracting that, whatever the runtime is. It could be Docker, it could be Rocket. And it's abstracting that concept of a node in the cluster. So we know what a kubelet is now. What is a virtual kubelet?
First of all,
pass it over to Brian.
I apologize for putting whatevs in there. Like I didn't know you were going to say.
I'm going to say it
so
I'm
much.
going to say whatevs every time.
So virtual kubelet, it acts basically just like a node in the cluster for the most part. Kubernetes schedules pods to it. It makes sure the pods run. That's it. We're done. See ya. So I can just replace the kubelet with virtual kubelet for some reason. No, not really. So the kubelet's really good at running workloads on a node, on a host, on a VM, whatever you want to call it, physical machine, it doesn't matter. It manages the resources on a node, does things like mount stuff from the host into a pod that you asked for, all this kind of stuff that the virtual kubelet actually will not do because we're specifically not targeting a real node that you would think about. But some things that you might use it for is bursting to some cloud containers as a service, which Microsoft happens to have called ACI, Azure Container Instances. AWS has Fargate. There's probably some I'm leaving out. Terribly sorry for everybody. It's done on purpose. There's other serverless platforms as well. I've seen people using it to bridge orchestrators. So like Mesos, I've seen working on a connector there to allow you to schedule from Kubernetes over to Mesos. I saw something else for Joyance Triton. It's cool stuff. You can schedule stuff. These are just ideas. You can schedule stuff like to an IoT control plane. Maybe these things have a persistent connection. Maybe they don't. When they come online, you want the stuff that Kubernetes said to run on it, and like flip an LED from green to red or something like that. I don't know. It's pretty cool. You can, or there's somebody in Microsoft made something a thing to order pizza. That is, I think that was a real thing, wasn't it? Yeah, it was real, and I'm sorry. So how does it work? That's pretty much it. Like, it's magic, but no, not really. It's not magic at all. So this might look familiar. Virtual Kubelet comes up, says, hi, I'm a node.
Hey, node.
User creates a pod. Kubernetes schedules the pod to Virtual Kubelet. We have a watch in Virtual Kubelet saying, hey, I want to see everything that matches this list of things that I should be looking for, specifically for the node name. It runs a state reconciliation to see what it needs to do. Do I need to create it? Do I need to delete it? Whatever. And then makes a determination, oh, I need to create this pod, so I'll go ahead and create it. So what does Virtual Kubelet actually look like? There's three main components. We have the Virtual Kubelet core framework that is kind of responsible for the Kubernetes side. We have providers that's kind of responsible for other stuff. He'll get into it in a minute. And we have the daemon that's kind of this Virtual Kubelet distribution that has all this stuff kind of pulled together. So.
Okay, so on that previous picture, we saw the daemon. It contains the framework and whatever provider you're going to use. So what is a provider? So in the grand scheme of things, what we're trying to use Virtual Kubelet for is to allow you to schedule the pod any way, like the normal way you would with Kubernetes, but have it run in something that doesn't really represent a node. So the provider itself is really responsible for doing that translation between what is a pod and what is that thing that needs to run. So in the case of ACI, we're going to make a resource or a container group and put any number of containers that match whatever containers you have in your pod. It doesn't necessarily have direct access to the Kubernetes API. It's a separate thing. And what it does instead is conform to the API that we provide, which is called the provider interface. And that provider interface we'll see in a second. But first, like, what providers do we have? ACI, we mentioned a second ago. AWS Fargate. VMware has one for vSphere integrated containers. So if you're running vSphere on-premise and you want to use Vic to abstract away resources for running containers, you can use that. There's one for AliCloud. There's one for Huawei. Brian mentioned the IoT Edge thing. We had a demo at our booth that was pretty cool. Somebody had this little robot from Anki that you can program, and they had a little edge device next to it, and they used Virtual Kubelet to schedule workloads to it, and it was doing computer vision and reading signs and printing the text out. And he was able to update that by deleting the pod, which ended up deleting the thing from the IoT Edge device and deploying a new workload to it, which contained the new logic. Okay, so let's jump in and see what the provider interface looks like. Do you have code open? Yeah. Okay, we're gonna make this bigger. How's that look? Too big? Okay, so let's collapse this down for a second and close this. So this is the Virtual Kubelet code base. It's in GitHub, and we'll give you the GitHub repo in a little bit. It's structured very similarly to how other Kubernetes code kind of looks. We have a CMD package that has like the root thing, other code that goes along with it. So that's like the entry point where the daemon code lives.
I like the root thing.
Yeah, the root thing. We have some examples. Providers, which is what I'm going to talk about right now. So in the providers package, you'll find all the implementations that we currently have. All those things live within the Virtual Kubelet code base. So if you want to add a new provider for something, you're welcome to submit a PR to add one. We're going to look at the Azure provider in just a second. But if we go down to provider.go, this is the interface that you would have to implement if you're going to be a provider for Virtual Kubelet. And as we walk through this, it's going to talk about mostly lifecycle of the pods. So create pod, update pod, delete pod, get pod. And then it starts to deal with some of the synchronous operations, like get container logs, exec in container, get pod status, get pods. And then it deals with things that are more node-like. So the kubelet really deals with a node, right? But we're not really a node. So we need to provide some of these things, like what conditions are available. Can we schedule to ACI? That'd be a condition. What capacity does my abstracted thing have? Like if we have an endless bucket of space, can we schedule forever? Or do we have a constrained bucket of space? Can we not schedule forever? So again, like all these things represent like the virtual node, so operating system. Is it a Windows or a Linux node? And then we also have an optional interface for doing stats. So if you want to collect stats from your providers, one of the things the framework allows us to do, this is an optional interface that you can implement. Okay, so really the provider abstracts away your end thing, and it's responsible for taking this interface and turning it into reality. So let's take a look at what one looks like. Let's go just look at the Azure implementation. So here is ACI.go. This is the Azure Container Instances provider, and we'll just walk through it and see what it looks like. So in here we've got stuff that's related to initializing an ACI client. So we're importing a bunch of ACI stuff. We're making a new provider here. Things that matter for Azure are like what region is it going to run in? What resource group do you want to use? Things that specifically matter for ACI is what operating system do you want to create the containers as? What kind of memory and CPU defaults do you want to give to it? Do you want to run it in a VNet? So all these things that are really Azure specific, not really Kubernetes specific. This thing is encapsulating and hiding from you and really only implementing that interface. So we can scroll down and we see it builds up stuff. We can see what regions are available. But then we get into the implementation of the interface. So I'm going to scroll down some more. Oops, did I miss it? Sorry. Yeah, nope, let's say provider. Here. Create. Ooh.
You broke the build.
Yeah, I broke the build, sorry. We're going to compile this right now. So here's where we start implementing that interface, right? So this is going to take a Kubernetes pod object. And Virtual Kubelet is not abstracting away what a pod is. It's dealing with pods, and it's expecting you as the provider to deal with pods. But you're going to turn that pod into whatever the real thing is that you need to deploy. So in this case, we're going to make an ACI container group. That's what the representation of a pod is in ACI. It can have one or more containers, can have ports exposed. It's really similar to what a pod looks like in Kubernetes. So we're just going to walk through that pod definition and turn it into the right thing for ACI. Then we scroll down, and eventually we use the ACI client to make that thing. Okay? So you do your pod creation. The scheduler assigns it to Virtual Kubelet. The framework in a second we'll talk about says, oh, I need to make this thing. And it uses the provider interface to actually invoke that. Okay, so that's what the provider interface looks like. And if we scroll through here again, you'll see more. Let's see, what else we have? Delete pod, update pod, which we don't implement yet. Get pod. So all the things you would need for those lifecycle operations. And then further down on this, we have some implementation of resource constraints and statuses for ACI. But we're going to jump back to the PowerPoint now, and Brian's going to talk about the framework. Where is your PowerPoint?
Safari.
Oh. Click to exit full screen. Back to full screen. Is that good? Nope. Is this it? Nope. Just make it full screen.
Sorry. Don't need it. It's okay. All right, so the framework, it's this thing that's basically a reconciliation loop. If you know what a Kubernetes controller is, that's essentially what Virtual Kubelet is, or at least the core framework. We work from a shared informer cache. That's basically this local cache that Kubernetes client provides of stuff that you're watching, and you might share this with other things if you happen to want to build your own Virtual Kubelet style daemon. We have an HTTP server for handling things like requests for logs and like pod exec, and these are all the synchronous actions that the Kube API server will call in for. And of course, we also add things like tracing and logging. That's just you kind of get for free by using the core framework. You can get some pretty awesome details in terms of how long it took to create this pod, and how long it took to go through the work queue and all that kind of fun stuff. So I'll take through some of the code for that framework. So we will go through that root thing. So this is just the main daemon implementation. We go through a whole bunch of setup stuff, like setting up the Kubernetes client, setting up the provider that the user asked for. These are all pretty basic things. I don't think I need to show them. So we create this vkubelet thing, and then we go ahead and run it. And this is where the magic happens, or the not magic. So this is in the vkubelet package if you happen to be following along in that regard. So you can see some of the things automatically. We've got this logger here that we pull, that we actually are extracting from the passed-in context. We start the HTTP server. We register the node. We start a reconciliation loop that checks the pod statuses from the provider and sync that back to Kubernetes. And then we have this other thing here that runs to sync Kubernetes into virtual kubelet so we can figure out what needs to happen. So we start up a work queue, go down to the workers. Some of this is probably, if you've written a Kubernetes controller, it's probably pretty standard. It's relatively simple. I don't want to say it's simple because it may not be. Pop something off the queue. You can see we got tracing in here. And we go and figure out what this thing is, and something happened. There we go. There we go. We run the thing that says go ahead and sync it, and if it fails, we add it back to the queue. We have a certain number of max retries, which is nice because things fail not all that unoften, especially while like ACIs and preview. So we get this info from the queue. We look up the pod from that key that we got from the queue, and we determine, do we need to delete it or do we need to create it? It's a relatively simple thing here. We're just syncing pod. We're getting notifications from Kubernetes, and we're determining, oh, does this pod have a deletion timestamp or does it not have a deletion timestamp? Do we need to create something or not? And we pass that along to the provider to deal with it. Let me see if I can fix this. I want to fix it.
There we go.
Cool. So what do we have coming up? Basically, we want to hit targeting a 1.0 release for probably March. So we have a whole bunch of stuff in GitHub labeled VK 1.0. Some of the things that came off the top of my head while I was writing this, port forwarding. We want to have metrics. So we have tracing already, but we don't have metrics for VK. So you can kind of track that stuff, and we just have to kind of figure out what actually needs to be measured. Support for external volumes. There's some more work to do to split the core virtual kubelet framework, the reconciliation stuff, from the actual daemon setup. There's been some kind of mixed up things in there. We're trying to split some of that out now. Things like supporting pod updates, which we don't currently support, even though there's not that much to update, but it's still important. Some stuff that all that stuff we need help with, but there's more. We want to make sure our provider interface is good to go, like it works for most people. We really don't want to have to change it after 1.0. So if you are thinking about writing a provider, please do give feedback on that actual interface. More E2E tests. We have some. It's not enough. Never enough. We want to pass conformance tests. Some things don't make sense, like we can't do host mounts. We don't support mount propagation, anything dealing with the host at all. So there will be some things that we expect to fail. But for the most part, we should be able to support things like right now we don't have the downward API support that we need to get in and some other things. And again, more work making the core virtual kubelet more of a framework that you can consume and potentially build your own thing that's not the daemon that you saw in the code base here. And bugs and missing features and all that fun stuff.
So we want you to help us. This is a pretty new project in terms of CNCF adoption, but it is a sandbox project now. We have a lot of work to do still on a bunch of things, and we think it would be great to have a lot of community support. If you have use cases, you can give us those if we don't meet them already. If you can think of other providers, if you want to work on any of those things that we just talked about, that was really the context for doing this deep dive. We wanted to give everybody a sense of how it works, how things are structured, how you can find things if you want to dive into the code yourself. We do have obviously there's a GitHub repo. We are in the Kubernetes Slack in Virtual Kubelet. You can join us and ask questions in there. If you want to dive in and find a good issue that's a good thing to start with, you can ask in there. We've got a couple people that are really encouraging new contributors. We have community meetings every other week on Tuesdays. Those are at 11 Pacific time. We do them on Zoom, so you can join us and have good chats. And again, Virtual Kubelet is a CNCF sandbox project. So we left a bunch of time at the end here to answer questions if people have questions. We can also do a demo if people want to see a demo. So it's kind of choose your own adventure now. If people have questions, go ahead and ask them now. And if there are no questions, then we'll do a demo and you can see. We're going to have Nick run the microphone around so that your questions can be recorded.
I thought you were going to do the any questions?
Yeah, any questions?
Oh, I don't think it's turned on.
It's not, yeah.
You didn't say I had to turn it on.
Yeah, that's right. Let me see, there's a switch in there. Obviously there's a switch. Why would I say something like that?
Thanks for interesting talk. And my question is about mock provider.
Mm-hmm.
If you could elaborate on how can we use it, and what are use cases of using it, and question basically, do you see if it's feasible to use it as the kind of integration to do this integration tests for operators?
So yes, so the mock provider, we actually we just recently added E2E tests, and we actually use the mock provider specifically for that. But yeah, it's totally just for testing out features. Maybe we need to add something to the core, and we just want to run that against something without having to fire up real infrastructure. Yeah, does that answer your question? Not quite?
Yeah, I guess not quite. Okay, for example, if if I create an operator, right? What I want to be sure that, for example, if a certain event happened, right, then a certain, I don't know, resources like deployment has been scaled, or I don't know, persistent volume has been something, and so on, and the status and the sub-resource of my CRD has been updated, right? So I want to write such kind of scenarios, and right now I feel that I cannot do this in Kubernetes, right?
Mm-hmm.
Oh, okay.
Using it to test operators, in the sense of operator framework things that you're building? I mean, not necessarily the operator framework, but a CRD
That's
operator.
right, yes. Well, or if I wanna, I don't know, run any kind of automation, for example, I write my Ansible playbook, I will eventually need something similar. Yeah, it really doesn't matter the operator or anything else, yeah.
I think that's a little tricky to answer. So first, yeah, you could totally use it to do that. So you fire up Virtual Kubelet and essentially schedule it to that with a mock provider, and that should work. But unless you're specifically looking to target Virtual Kubelet, I would recommend looking at the kubelet. I don't know what they might have available in terms of dummy interfaces for CRI. But that would, to me, I would try to look at CRI integration to do that. So you're running on a real kubelet if that's where you're expecting to run your stuff.
So I assume virtual kubelet is calling into the kubelet API and receiving API calls from the server API. So is the kubelet API a stable Kubernetes API or?
So the kubelet API is pretty thin. It's really scoped to those synchronous operations, like execing into a container and getting logs. The other parts of that are really driven as just being a Kubernetes client. It's not really a kubelet API. It's just watching for pods or watching for services, those sort of things.
So the virtual kubelet is monitoring what's happening and
yeah, it's operating just so if you dig through the kubelet code, you'll eventually find the spot where it sets up a watch, usually in just a Kubernetes client with client Go, and virtual kubelet does the exact same thing.
So, but I assume it's watching for certain REST operations, and how do you guarantee that if I throw a virtual kubelet binary into my cluster, it's actually going to watch for the right things depending on the Kubernetes version I'm running on my cluster?
Sure. Yeah. So you want to take that?
Sure. So basically, the only thing the kubelet does is really anything. You make changes on the API server, then everything else is just reacting to those changes. So like the kubelet is looking for stuff that has been scheduled to the node name of that node that the kubelet's been registered with. And likewise with virtual kubelet, we're just watching for things that are scheduled to the node name that we specified when you started virtual kubelet. So like when it's time to create a pod, there's nothing telling the kubelet or the virtual kubelet, go ahead and create that pod. It's just, this is now in the API server. Then the scheduler even come and say, oh, someone's added a pod. We need to schedule that. It's not been scheduled yet. So it goes and updates the pod with the node name that's going to be scheduled to. And then we look at that and say, oh, there's something that's been assigned to us.
For us, okay.
Yep.
So then, just another question is, when you start a virtual kubelet and bind that to some providers somewhere in AWS or Azure, what kind of resources do you advertise? I mean, how do I make sure that I only schedule specific workloads on through this virtual kubelet?
Yep. So there's a couple things there. There's two parts of your question, I think. Right now, it's up to the provider to report what resources are available. In ACI, we don't do a very good job of that. It's one of the things we should do better. We say that it's like pretty much an endless bucket, and ACI does have quotas, and
exactly.
run into those.
It could look very attractive to the server API, saying, "Oh, this is this is a huge node."
Right now, what we do is when the node is registered, we taint it. So you have to explicitly opt into using virtual kubelet right now. So when you deploy your node, like virtual kubelet runs as a pod in your container. It can run other places as well, but you can find it. So when you register it, it starts up. It has a default taint built into it, and it's overridable and you can change it. But by default, when the node starts up, it comes up with that taint. So things won't get scheduled into it unless you specify toleration.
You taint your pod?
Yeah, you have to specify toleration on your pod. So this is an example of something that will run on virtual kubelet. So you can see it's got toleration at the bottom.
Toleration, okay.
Yep. And the other thing you can do is, because that's configurable, and this one says Azure, you can run multiple virtual kubelets to get multiple nodes. Like if you want to run some pods in Azure, and you want to run some pods in ACI or in Fargate, or you want to run some pods on-premise with Vic, or maybe you want to burst from your on-premise stuff out to a cloud provider. You can use multiple tolerations there to allow it to run in different things.
So I have a question about if, so I'm sort of thinking about like, did it go away? No, okay. If you're going to do a new provider, it seems like the model you're working on is basically that your provider is an infinite sink, and which is probably true for essentially all ACI customers, right? At very large capacity, and that it's, I assume you're just expressing the node into the API server as like very, very, very large capacity.
Yeah, right now we are free.
And so I'm sort of curious, do you actually think virtual kubelet is compatible with something that has a much more finite capacity, or should it always sort of be used with providers that you can, more or less treat as an infinite sink just due to the capacity of the provider versus the relative size of customers' workloads?
Yeah, so the provider interface allows you to specify those things. You could give realistic numbers for that. VMware does that with Vic. It's not I don't think they represent it as an endless pool of data. It's possible they do. But you could make it be realistic and be more node-like, even though it's not a node, right? It's a more elastic capacity or more generic capacity.
Sure. And so like one brief follow-up to that. So how does ACI deal with maintenance of the actual stuff that's running virtual kubelet workloads? Is it that you basically just, kill pods and then
They'll come back up and
Yeah.
So we're running two reconciliation things, right? We have one that's looking at stuff in ACI or your provider, and it's querying the provider, so your provider reports status back. And then we have one that's looking at Kubernetes. So if something's going to die in, ACI will restart it for you. It's like how ACI works. But the provider interface allows you to do that too. So if it died in whatever the underlying system is. But for ACI, you can do all kinds of things like define readiness probes and liveness probes. It looks very similar to like the Kubernetes pod spec. And ACI will, because it's a managed service, will do a lot of that for you, specifically for ACI.
Yeah, I have two questions. One is that if you need to go with two providers, or two or more providers, do you need to run virtual kubelet multiple times,
Yep.
or is it?
Right now, it's configured to have one provider, like per instance. So you would want to run multiple pods because it's going to register as multiple nodes, right? Like in that case, so you would want to run one per like variation of virtual kubelet. So for us, you can run Windows containers with AKS by doing a virtual kubelet to Windows, and you can do Linux containers to ACI via virtual node, or sorry, by virtual kubelet by specifying Linux as the operating system for that node. So you're running two VKs in that case.
Okay. And second question is that networking. How does networking work now?
That's a good question. That's kind of up to the provider. So in the I'm going to use ACI as another example. In that case, we support a couple of modes. When you start VK up, you can specify that you want to use a VNet, which is like what you'd use to do private networking between like an AKS cluster and ACI. So in that case, it kind of looks just like one network. If you don't use that, one of the default behaviors for ACI is to create a public IP for things. So when those pods spin up, they'll have public IP addresses. They won't necessarily be able to see things back in the cluster. So you got to kind of take that in consideration when you're thinking about what workloads are going to run there. It's definitely not a generic replacement for a kubelet or for a node. It's going to be for those specific use cases. And you have to kind of consider that with the topology of your network and just how VK and the backend provider are configured. Take the mic back. Oh.
For things like exec, when it doesn't really make sense in the particular context, how do you handle that?
We handle exec, actually. So we do, right now we do exec and logs. We're looking at how to do port forwarding, but I think that's going to be mostly up to the provider. I think, yeah, for those API requests that come in like that, I think we support most things. I'm not 100% familiar, but
yeah, like exec is implemented in the provider too. A lot of those things are in the provider interface, and it's kind of up to the provider if it makes sense or not.
Yeah.
Like for ACI, there's a API operation you can do that makes sense. In the VMware Vic on-premise scenario, you could probably also do that. Other things might not make sense, like especially that IoT case, right, where you're like deploying to some IoT control plane in the cloud, and it's doing asynchronous operations to end devices. So it's kind of up to the provider to implement what makes sense.
yeah. So we'll wire up the HTTP server, send them and pull in their IO streams or whatever we need to do, and send it to the provider.
Okay, so like in that case, if like it didn't make sense to have an exec function for the particular workload, you just like return an error, I guess? Okay.
Yeah.
One of my questions got answered, so that's good. The other question is, are you able to handle secrets and config maps and other objects like those?
Secrets and config maps, yes. Nothing else.
Like volumes and stuff like that? You said they're not supported?
Correct.
All right, thank you.
love how you guys are all on the opposite sides of the room.
Just trying to make you work a little. So you would do, it's one virtual kubelet per provider, which say, for example, I want to have 2 different configurations for the same type of, so I like ACI configured this way and that way, I would have them, they would represent. Is there any way or thought about overriding any of the provider configs via the pod spec, where it's like, hey, we have this configured this one way, but if this comes in via the, as extra configuration in the pod spec, we can pass that down, or?
I think that would always be up to the provider, because we're
Okay.
in VK, we're not parsing it.
Okay.
Yeah.
So that would be possible because you're passing the whole pod spec to the provider.
Yep.
So if they wanted to do that, that would be up to them.
Yep.
Cool.
Yeah, I mean, you could totally ignore the pod spec and order pizza via the Domino's API too. So somebody built that on Monday. We had a workshop at the reactor, and he built a Domino's ordering provider. So you could schedule a pod, and it would make a pizza.
Anybody else?
Do you support static scheduling?
So what does that mean?
Yeah,
Kubelet supports static pod scheduling, like they exist,
yeah.
like how it's used for in manifests and add-ons. So I'm wondering if you support that without relying on the API server?
I don't think we do. I'd have to check. Because all virtual kubelet is doing is listening for pods being created and passing the spec on to the provider, which doesn't have API server access. I don't think we do.
So if you had a static manifest and you had the taint toleration set up,
Yeah.
you could schedule something out to ACI with static manifest, but I don't think that's what you're asking.
No, not exactly, no. I was just wondering if I can operate the virtual kubelet, I can misuse it such that I run it without the API server, but only to fake pods that they think that they're running into Kubernetes, but they're not.
You would have to stand up a control plane to do that, yeah.
All
Because
right, I'll talk to you about it after.
Yeah.
Yeah, that's interesting.
Right up here.
Anybody?
Yeah, this
Yeah,
guy
right here.
Oh, he was raising his hand. So it looks like you're-
The question is, what do you guys mean when you say that VK doesn't support storage? Because maybe I'm misunderstanding how things work. That sounds something that ACI is supposed to handle, not VK. So I'm confused about that.
Yeah, so probably like volume support would come out of the provider. But
volumes in ACI.
Okay.
So we do support in virtual kubelet, like Azure files, empty dir, and there's Git repo, I think. So we do support some.
Some.
Just not like,
Yeah, not the whole gamut of things.
yeah, they're like disk map, other things.
Okay, so that means that every other API or Kubernetes resource or should be supported as well, or there is if not, what's the challenge? Because I imagine that ACI is another Kubernetes instance running, but with an abstraction level, a higher abstraction. So I don't see why anything wouldn't work.
Okay, so the provider gets a pod spec, and if it's in the pod spec, they can do whatever they want. We do not give them access to the Kubernetes API from virtual kubelet. It doesn't stop you from wiring in your own client and pulling objects down to do what needs to happen. But VK does not right now provide any way to grab those kind of other objects, which we'll need to figure out. The only two things we give it access to are fetching secrets and config maps. Does that answer it totally?
But
No, but I'll research more, and I'll have more questions. I have the Slack channel.
Yes.
yeah. Talk to us in the Slack.
Any other questions? Cool.
Would any of you gentlemen care to drop the mic?
Thanks.
I don't think you'd like that.
Yeah, so if we have stickers, come get them. We have a whole bunch of them.